Hello, everyone, and welcome to our meeting of the Champaign Blockchain Meetup group. Today, we have some folks from Runtime Verification, a company based here in Champaign-Urbana, adjacent to the University of Illinois. Their projects include the K-semantic framework, in which programming languages, type systems, and formal analysis tools can be defined using configurations, computations, and rules. It's an exciting project because it allows for interoperability between languages when these definitions and structures are made. They also do smart contract analysis and verification on the Ethereum blockchain and perhaps others, and are developing Yella, a K formal specification of the Ethereum virtual machine that will hopefully be another step forward in this space. So I'll turn it over to Patrick MacKay and Everett Hildenbrandt. And thank you, gentlemen, for being here today. And yeah, we'll turn it over to you.
Well, Adam, thank you very much for having us. I think Everett will probably share the slides, and then we'll just move through. I think I'll provide a short introduction, and then Everett will obviously take care of and kind of dive into the meat of the presentation.
Can you guys see the slides?
Sure can.
Yep.
Okay. I'm worried it's going to do the autoplay thing. So, all right, Patrick, take it away.
All right. Yeah. So once again, thank you very much for having us. It's nice that obviously we would prefer if we were all together. You know, for example, if we were all in Enterprise Works over in the research park. But you know, this will definitely do for the time being. It's also exciting to actually chat with folks that are local, right? So, you know, Everett's given a couple presentations the last couple of months, and obviously they've been virtual, but the audience themselves have largely been focused on either the European or Asian markets. And we are also joined on the call by one of our newest hires. She's our marketing lead, Sylvia Barreto. And she's actually joining us from Barcelona. So hopefully she actually has a glass of sangria in front of her, because for her, it's obviously getting later in the evening. Okay, so let's go ahead and get started with just a general company introduction. If you go to the next slide, Everett. Okay, so this is a lot of this, what you're seeing here. You can obviously read the text here, but just to kind of give you an overview, the company itself was founded in 2010. As Adam mentioned, it spun out from the university, right? It spun out specifically from the computer science department. It spun out from a lab, the Formal Systems Lab, which was and is still led by Professor Grigori Roshu. So Grigori is one of the foremost experts in programming languages worldwide. And the idea behind spinning out the company in 2010 was that the company was going to commercialize some of the tools, the technologies, the research that was being done at the lab itself. Specifically around the embedded space. So for the first 7 years or so, the company largely worked on R&D projects, or actually worked with R&D teams inside of embedded companies. So think things that move, right? Planes, trains, automobiles, space shuttles. So we were working with the folks that were actually writing code pre-production to make sure that that code was doing what they thought it would do, both from a function and also from a security perspective. We were also at that time we had a handful of government contracts that were being used to fund development of our core technology. In 2017, Grigori was approached by a couple prominent folks in the blockchain space, and they asked him point blank if the company had considered applying its tools and technologies to smart contracts and protocols, both from singularly from a verification perspective. At that point, I don't think anyone at the company, was still quite small. It was largely mimicked in terms of size and operations to the lab at the university. So at that point, I don't think anybody, maybe Everett was the only person, because he was actually studying for his master's at that point. Maybe Everett was the only person at the company that actually knew something about blockchain. But the rest of the company did not. And so the point blank answer was no, the company had not looked at that opportunity. But like any good researcher would do, Gregorian and the team did some initial due diligence and quickly realized that it was definitely an opportunity worth pursuing. And if you fast forward to 2021 to today, we probably generate more than 90% of our revenue from professional services engagements in the blockchain space. So we work with folks, so we work with the infrastructure builders, right? So we work with the layer one chains themselves, of which you can see here on the slide. So Adam, you're right. It goes above and beyond just working in the Ethereum space. But we also work with folks that are building products and services to run on top of that infrastructure or powered by that infrastructure. For example, we have a wonderful, wonderful relationship with the folks over at Maker, right? And obviously they're one of the premier applications or use cases in the Ethereum space. In terms of manpower and people, we have 18 people here in the States. We were already moving to more of a decentralized model before COVID, but that's really kind of it accelerated that development. So we do have an office in downtown Urbana, but we do largely work remotely regardless. And then we also have 15 people on the other side of the Atlantic in Europe that are working on a variety of different functions and projects for the company. I think that's probably a good overview. Obviously, more than happy to answer any questions that you do have during the presentation, after the presentation, and would definitely look forward to doing so. I'll now pass it over to Everett to go into the rest of the presentation.
Thanks, Patrick. That was a great introduction to the company. Sorry, there are more slides here, but I forgot I should be scrolling through them. But yeah, just some kind of high-level accomplishments we've had in the past. You know, it all started with this one down here in the middle with KVM, which was a class project starting back in 2016. And it was IOHK that actually approached us and they said, hey, you know, would you like to turn this class project into kind of more of a commercial venture? And so they actually funded both some research at the university and the expansion of the company to kind of commercialize what it was we were creating as more of an academic endeavor, actually. So it's kind of the classic academic success story, if you will. And since then, obviously, we've expanded way past just working with one company, as shown on the previous slide, to working with lots and lots of different companies in the blockchain space, both layer one chains, like Patrick mentioned, so Ethereum, Cardano, Polkadot, you know, Tezos, Algorand, Cosmos, all these different chains we've done work for, but we've also worked with just smart contract systems on individual chains that'd be like Maker and Stakefish, Uniswap, Stakewise, so all these different organizations. And then there's some kind of non-technical, more community-oriented organizations we've worked with as well, like the Ethereum Trust Alliance, Ethereum Enterprise Alliance, these sorts of organizations that are trying to organize the chaotic development that is happening in the Ethereum ecosystem and also kind of create standards of safety for Ethereum smart contracts. You know, there's a lot of standards of safety that exist in traditional finance. We can argue whether or not those are working or not, but at least they exist and they're trying to do something. We should do something similar for Ethereum smart contracts and other chains as well. And I guess we'll share the slides after the meeting so you can take a look at some of these more detailed slides afterwards. Yeah, so what I'll be talking about more is the technology aspect of what we do. And at Runtime Verification, everything is powered by this K framework, which has a bunch of different components to it, and it's hard for people to kind of wrap their head around, but it actually started as just programming language research into how we design and build programming languages in Grigori Roshu's lab at the university, and expanded into kind of an actual practical tooling framework that can be used for building new languages and also making tooling for existing languages. So I'll talk a little bit about that, but the basic idea is you write down in our mathematical formal language called K, the semantics, we call it, of your language, like C or C++ or Solidity in the case of Ethereum or EVM. And from that, you get to derive a bunch of tooling kind of for free, quote unquote. The traditional approach is instead, you would say, I want to make a I want to make an interpreter for C, and I want to make a compiler for C and a model checker for C, and all of these are different programs. And so you don't know if, all your different tooling agree on what it means for something to be a C program. First, you have that disagreement between your tools. Maybe your model checker thinks that this part of the C program should be executed in this way, but your compiler thinks it should be executed some other way, right? And that can cause kind of a disconnect between efforts of these different tooling, but it's also kind of a wasted effort, because now if you now go to Java and you want to make a compiler for Java, you have to redo a lot of the same work that you put in making a compiler for C, for example. So actually, for compilers in particular, LLVM is a very similar project to K in the sense that it provides like a single IR that can compile front-end languages down to, and then LLVM will target a bunch of backends for you. And K is kind of a similar approach, but for formal methods and formal verification tools. We provide a single language you can provide the semantics for, like this, and then K will automatically generate on the right-hand side all these different tools that you need for your language to make it to do practical anything with a programming language. So this is a huge economy of effort, basically, because you can have a person who's a model checker expert develop the model checker, which is language independent, and a person who's a JavaScript expert develop the JavaScript semantics, and they don't have to worry about each other, right? And when the model checker receives an update, it updates the model checker for all the languages we have. Or when JavaScript receives an update, all the tools get updated in sync, right? So that's kind of the overall like research vision that came out of the university and Grigori Roche's group. And it's not like it, there were there's lots of attempts to do something like this, but K is kind of the first commercially viable attempt to make this work, I would say. So what is K? K is technically an operational semantics framework, which means it's a mathematical system for writing down what it means to execute programs in a programming language. So you can write down, like, if I want to execute a while loop in this programming language, I have to take this step and this step and this step. So first I have to check, is the Boolean condition in the while loop's condition block true? And if it's true, then execute the body of the while loop. If it's false, skip over the while loop, right? So that's the type of thing we write down in what's called a K specification. And then K itself derives all these tools based on that specification from that. Architecturally, K is split into two main components, or two main backends. At least the current existing implementation of K is split into these two main components. It used to be there was only one, and then there were four, and now it's down to two. So this is just kind of the current incarnation of K. There's the LLVM backend, which is generated code from your semantics to provide a fast interpreter for whatever language you have. And we actually, for example, for KVM, which is our K semantics of the Ethereum virtual machine, we are comparable and we're faster in performance than like the Python implementation or the Ethereum JS implementation. And we're within an order of magnitude or so of performance of the C++ implementation of the Ethereum virtual machine. So even though we're deriving the interpreter from a mathematically sound specification, we're actually able to achieve high performance using this LVM backend. The Haskell backend, on the other hand, is for symbolic execution. So it's used to do verification or model checking, anything where we want to, absolutely be certain that a given program has the behavior we want. We use the Haskell backend for. As I said, all the tools built by RV are powered by K. And you can go to the website here, kframework.org, if it will open. Can you guys see this screen now? I'll take the silence as a yes. And it has kind of an overview of what K is, as well as where you can go to get downloads for it. So you can go to the stable release or prior releases here. These are actually just hosted on GitHub, so it'll open on a new tab there. And we provide packages for all sorts of different things. So you can go and experiment around with the tool and documentation and kind of a standard library of built-ins here, and then a list of projects that use K as well. So you can kind of get an idea of what's being actively worked on in the K ecosystem. So that's kframework.org. You can go there anytime. Real world K. So, K started out as an academic project, as we stated. And initially it was just used for kind of academic endeavors, right? Like, can we make a verifier for a language like Java? Or can we make something that finds undefined behavior in C, right? So it's kind of these, little experiments. But actually we realized, hey, you know, K is becoming performant enough, we can productize part of these things. And so on the left here, we have kind of our embedded system products, RV Predict, RV Match, and RV Monitor. And these target more of our, what Patrick was saying, things that move. So like trains, planes, and automobiles type of customers. So for example, RV Match is kind of our most popular embedded systems product, and it checks C code that's going to run on some embedded piece of hardware in a car, like on these little Denso microprocessors that are put in Toyota's cars. It checks them for undefined behavior. The reason being that C has a lot of undefined behavior in it, and that's actually that's an intentional part of the C standard that lets the compiler optimize away pieces of code that exploit that undefined behavior. But if you're running it on an embedded system, you don't want to leave it up to the compiler to decide what your code does. And so RV Match goes through and checks, is there anywhere in your program that you could run afoul of undefined behavior, and thus your little embedded system will have undefined behavior and your car might do something weird. On the right-hand side, we have more of our blockchain clients. We have Firefly, which is our testing and lightweight verification tool for Ethereum smart contracts and also other blockchains. We also have a token verifier, which is kind of an automated tool you can dump Ethereum smart contracts into, and it will tell you, yes, this is an ERC20, or no, this isn't an ERC20, and here's why. So that's good for people who want to interact with external ERC20s that maybe they don't trust. And then another example of a non-Ethereum tool we have is Yele, which is a language we have designed inspired by LLVM for the Cardano blockchain. This is a slide that kind of takes you through the what we've done in the KVM ecosystem. We have online generated documentation directly from the formal semantics itself. It's similar to the K generated documentation, but I'm not going to go too much into the details here, but it just kind of tells you this is how we define our semantics in K. Everything is done literally, so the idea is that, you know, the code itself should be explained and documented online, to make it so that people can have high confidence in the implementation here. So this file here, which has the documentation inline, is actually exactly the K formal specification of the Ethereum virtual machine. And then we've done a lot of projects with proving things in K. So we started out, I won't go too much into depth here because it might be a little too detailed. But we've had lots of different engagements with clients in the past where they've asked us to, you know, verify a piece of code, or just do some sort of lightweight audit or something like that. So we've developed various tools for doing exactly that. And so kind of the most gory detail thing we can do is this, which just looks like horrible, I know, but what this is basically saying is your code behaves correctly, absolutely will not mess up, right? And so if we write a file like that, that's what we get. But that kind of takes a while for us to do. And that's to make sure, for example, that the transfer function of an ERC20 contract on the Ethereum blockchain, you know, behaves exactly how it should. It doesn't lose funds, it doesn't send funds to the wrong person, etc. But we have other more lightweight tools. So we have an example, the early on V1 of Uniswap, which is really popular DEX that's online now, is was one of our earlier clients actually for V1, and we found some kind of critical bugs in the Uniswap market maker model where you could get arbitrary exchange rates by kind of messing with rounding errors in the contract itself. So you can look at an example of what a report that we would generate for a client for an audit would be. So here's an example report, for example, where we formally specify the market maker properties that they were looking for, and then you know, show how there could be rounding errors and there could be other issues like that. So you can read through this on your own time if you have more questions about that. So throughout our, you know, company's history, you know, we weren't really sure what it was that people would be wanting from a company like Runtime Verification, the Ethereum ecosystem. It's kind of taken a lot of experimentation for us to figure that out. And we started out thinking, oh, people will want, you know, full formal verification. And that's what we offered at first, is just, we're going to go through and we're going to make sure your contract will not ever mess up, right? But that ended up being a very expensive and time-consuming process. And so then we developed this kind of lightweight auditing technique for this Uniswap one, which we've had more clients be kind of interested in that one because it's quicker, and they get results back quicker and they can launch sooner. But then there's sometimes like the ETH2. So there's this movement from Ethereum to Ethereum 2.0 where you have to move your Ether into the new ecosystem. And there was a smart contract that was responsible for doing that. And so they actually wanted, because everyone's Ether was going to be moving through the smart contract, they wanted full formal verification for that. So we went through and we did that. And we actually found a pretty serious critical vulnerability in the code, and it was because the Viper compiler, or the initial contract was implemented in Viper, which is a different programming language than Solidity, and the Viper compiler introduced a bug into it. And so we had them rewrite the contract in Solidity, or they agreed to rewrite the contract in Solidity, and then we redid the formal verification on the new contract, and we were able to say, yeah, this contract won't mess up. So that's an example of another success story. And then another one is the Maker system, the multi-collateral die system. They actually are kind of the biggest users of K outside of runtime verification as Maker. And they actually formally specified and verified the entire multi-collateral die system, which is quite an impressive feat because there's a little over 1,000 proofs involved in doing that. And they're all specified here in this repository. And I don't know, it took them a few months and we just taught them how to use the K tools, and they kind of did it themselves. This was early on. I want to say early 2019 or maybe late 2018 that we were working on this with them, and we're all pretty impressed with that effort. Actually, it still remains to date kind of the largest formal verification effort I've seen in the Ethereum ecosystem. So that's kind of cool. Some more examples of things we can do with K is based on KVM. We have this Firefly tooling. It's kind of our developer tooling for smart contracts. And there's a video on an about page you can go through and look in a little more detail.
Everett?
Yeah, what's up?
Could I say something real quick?
Yeah.
So I think one of the other things, as we're talking about, some of the things that we're particularly proud of, or success stories. I think one of the biggest success stories is the fact that K itself is programming language agnostic, right? And that is reflected in the client list that you've seen previously in the presentation, right? So a lot of folks that are in the security space, right? That larger security space in blockchain have really put all their eggs in one basket. And, predominantly those folks have put their eggs in the Ethereum basket because that is, it's the second largest ecosystem if you look at market cap, and obviously there's a lot of action even in the enterprise space. But what we've been able to do is actually work with a variety of folks, and I think that's actually set us up quite nicely in the long run, because again, if blockchain is successful, it's not going to be the one chain to rule them all type situation, right? You're going to have you're going to have viable blockchains that are successful and flourishing because they are servicing particular use cases or particular industries. And we fundamentally believe that is what is going to happen. And so we've, as a result, positioned ourselves to work with folks across the board. But yeah, just wanted to add that part. Thanks, Everett.
Thanks, Patrick. Yeah, these slides are a little bit Ethereum specific because I kind of stole them from another presentation, but Patrick's absolutely correct. Like all of this tooling that I'm showing you, actually, we have all the same stuff for other blockchains as well. And we actively work with, I want to say, 6 different blockchains right now, 6 or 7 different blockchains right now, producing all the same tooling for them. And because of this, the way that K is designed, we have this economy of effort, right? We don't have to rebuild a model checker or rebuild a verification framework for each different blockchain. We can kind of reuse the same framework and just retarget it at the new blockchain by building the semantics for whatever language they're using under the hood. One ecosystem that we're particularly involved in is all the WASM-based ecosystems, because there's several blockchains that are using WebAssembly under the hood as their execution engine instead of the Ethereum virtual machine. And we have a semantics of WebAssembly, so that means that with very little effort, we can handle all of these different blockchains. So that includes like Polkadot and Elrond like COSM, WASM, some other, a bunch of other different blockchains that are using WASM under the hood. I do want to go through a couple of more user-oriented tooling that we've developed over time. So this is our attempt to productize some of the tools we have. Firefly, for example, is a tool that can be used as a test runner and test coverage for Ethereum and for other ones. We also have it for WASM and for Tezos, and we're thinking of developing it for Algorand as well. But it basically just gives you this these reports that tell you, okay, you know, your contract test coverage is not high here, or it needs to be improved here, but it gives you a very detailed kind of report about that. So you can explore this a little bit more in your own time, but the main advantage we have over other coverage tools is that we present the coverage at the bytecode level rather than at the solidity level. So it's a little easier to see why it might be that a line here, for example, this line of solidity code corresponds to 49 EVM bytecode instructions, and only 11 of them are covered. So you have to think, okay, why is that? Well, it's because I don't have any tests that make this requires clause fail, right? So that's kind of the idea here, is you have this really detailed coverage information, and then we also have, as part of this tool, random testing. So it can increase your coverage kind of by just exploring different random paths in your program and saying, hey, here's an input that you didn't try yet, add this to your test suite. And so this is to help developers improve their own test suites before they try to reach out for a security audit or something, which is an expensive and time-consuming process. Another example of a tool is the ERC20 token verifier we have. Once again, same technology, applies to other blockchains. This one's focused on Ethereum and the ERC20 standard, but you can dump some bytecode into this, and then it will come back within a couple of days and say, yes, I was able to verify that this is indeed an ERC20 and it conforms correctly, or it'll come back and say, no, this isn't an ERC20 and here's the reason why. So that's one tool that we kind of have in beta mode that we're prototyping. And we have a bunch of other planned features for Firefly, and all of this, once again, powered by K, and applies to all these other blockchains that we have as well. So, for example, we mentioned KYele, which is the semantics of Yele, a language we designed actually, starting back in 2018 and restarting again this year for the Cardano blockchain. And it's more like LLVM focused than the Ethereum virtual machine. So instead of being stack based like the Ethereum virtual machine is, it's more register based like LLVM. And the bytecode, or the assembly language for it, is actually more readable than that of EVM as well. So you could write your smart contracts in Yele directly, although we're providing a Solidity to Yele compiler as well. So you can just write them in Solidity too. And you know, similar for all these other things, we also have the Nicholson semantics here, which is for the Tezos ecosystem. And so we can do verification of Nicholson smart contracts. We have WASM for Polkadot, Elrond, COSM WASM, other ones. That's kind of one of our more mature ones. I don't have a link to these yet because they're not public yet, but we also have KTeal and K-Algo Clarity. And then once again, this big list of other you know, contracts that we have. Like we have more experimental theoretical ones like Boogie, which is a verification tool produced by Microsoft. So for example, it's kind of funny because Boogie itself is a verification tool, and we made a formal semantics of that. So now we can verify programs in that verification tool. So it's a little bit of a funny thing for us at least, but x86 we have a semantics of, so we can, you know, do things with x86 programs. So a bunch of different things we have semantics for. Once again, for all of these languages, we develop all the same tooling. Right? That's kind of the economy that we get by using K. This is just kind of a broad overview of our more blockchain-focused K tooling ecosystem tree, just to give you an idea of kind of how it all branches out. I mentioned there's kind of two main branches. We have like this concrete execution branch with the LLVM backend, and then the symbolic execution branch over here. And then based on symbolic execution, you know, we derive a bunch of other tools based on that. So here, if you go up to our theorem prover, then you go up here, you got our ERC20 verification tool, the one I showed a little bit before. But we also have like a symbolic testing tool based on that, right? Or an equivalence checker, which you can use to check that, for example, the Solidity optimizer didn't change the semantics of your Ethereum program. And then on the concrete execution side, we have, our test runner, our test coverage, which I showed, also test case generation. That's kind of our random tester, and then a bunch of other tools as well. Yeah, so once again, all of this is powered by K. That's kind of Runtime Verification's core motif or core motive, is this idea that language design and language development should be done in a first principles sort of way. A lot of language design historically has been done kind of ad hoc. People will write like a little Python interpreter, a little C interpreter for their language, and they'll be like, oh, I think plus plus should do this and this should do that, and they won't write down a mathematical description of what it means to execute programs in their programming language, which means that doing analysis of those programs becomes more difficult. If instead you start with a mathematical description of your language and then derive all the tooling from it, then you kind of get all that mathematical analysis and being able to do formal verification for a lot cheaper than if you were to do it after the fact. So that's kind of the extent of the presentation I have prepared. I'm sure no one will complain to get some time back, but I just want to say here at the end, we are hiring aggressively, so feel free to apply if you fall into any of these categories or you think you could. And yeah, thank you. Any questions?
Yeah, thanks. Thank you guys so much for the presentation. If anybody wants to just jump in, just go ahead and take the mic, and we'll make this pretty informal.
Hi, I got a question for Patrick. Could you talk about the Alpha Frontier project with Cardano and some of the things you're working on with that?
Yeah, so who asked that question?
Sorry, this is Tamara, but Arjun is in the room with me. Arjun
Okay.
down in Chile.
Hey, Everett, do you want to, you can probably stop. Yeah, there we go. So Alpha Frontier is something that we've started to put together the first quarter of this year. And it's really the brainchild of one of our newest hires, Tom Lindeman. So Tom is the Chief Strategy Officer at Runtime. He was previously at Consensus, and he built up their Consensus diligence practice, and also he was the founder of MythX. Okay, so Alpha Frontier is the focus there is working with layer one chains and dApps and the folks that have actually built the applications to port those over to different ecosystems. And when you port those over, to formally verify them using our technologies. So the idea is that that new application that's ported over to the new environment is and this is obviously a marketing term, would be bulletproof, right? Would be formally verified, super duper secure. So you could, for example, you would take something like Aave, right, which is obviously designed as a lending platform, lending provider for the Ethereum space. Well, you could port that over to Cardano, and then you'd be looking at a fully formally verified version of Aave for Cardano. It's something that we're still working out, but we do have a great partner that's obviously interested in that service with Cardano, and obviously a big cheerleader, if you will, with Charles Hodgson, who is obviously he's the head of IOHK, the technology partner behind Cardano, and obviously the one of the founders of Ethereum. Does that answer your question?
Yep, thank you.
I had a question. Has your work been influenced by TLA Plus, or do you have any thoughts on TLA Plus, how that compares to K framework?
Yeah, I can field that one. TLA Plus is another modeling framework. It's also actually based on kind of similar core technology as K, which is these kind of first order rewriting formalisms. And a typical TLA Plus model, you would define what your states look like. You would define state transitions, and then you define some sort of inductive or co-inductive transition relation, and maybe you do some model checking over that by stating some LTL formulas over that, and it will, by using predicates over pairs of states and stuff like that, try to show that your model can't ever reach a bad state, or it can't ever violate some temporal property or something like that. So it's actually pretty similar to K in the sense that it's inspired by the same first order world. In TLA plus, you're working in just sets and functions, and similarly with K, you're working with power sets and functions. So the models of K and TLA plus probably have very nice mapping between them. I think TLA plus tends to be a little less operational. I'm not sure how detailed of an answer you want here, but TLA plus tends to be a little less operational. So you can do more abstract modeling with TLA plus, but you might not be able to extract an executable specification from that, for example. K is focused entirely on operational specifications, so that you can always extract an interpreter from a K definition. Otherwise, I think it probably just boils down a lot to ergonomics and which tools are available, right? So if you if you want to do temporal model checking of liveness properties, probably TLA plus is going to be a little easier to use. But if you want a semantics that you could do functional correctness verification with and derive an interpreter that agrees with your functional correctness results, then maybe K is going to work a little bit better. K has been engineered from the start to be commercially viable and performant, whereas TLA plus, at least my impression. Now, keep in mind, everything I'm saying about TLA plus is from my limited experience with it, so I can't. If I say something wrong, please correct me. But I believe TLA plus is not as much focused on engineering and performance as K is. So that's basically my knowledge of the difference between TLA plus and K.
Great, thank you so much.
Question for you, Kavinda. I know that so the folks in the Cosmos space, right? So they're, and I'm blanking. Oh, sorry, the new entity, Informal Systems, right? So they're doing a lot of verification work in TLA plus for that particular ecosystem. Have you taken a look at them, or have you looked at Cosmos in general? I was just asking because generally speaking, when we hear about TLA plus and the blockchain space, it's kind of interchangeable or intermixed with work that's ongoing for Cosmos.
I have not. This is the first time I'm hearing it. My experience with TLA plus was very, very brief, and that was many years ago when I was in the distributed system space. The reason I actually ended up coming to this meeting because I saw runtime verification and brought back some memories of TLA plus. So I wanted to see what the latest is with respect to the blockchain.
Yeah, so I mean, if you, like I said, if you do want to kind of see how it's being used in the blockchain space, definitely take a look at the Cosmos space. Look at Informal Systems, and then the company named Informal Systems, and also maybe take a peek at the different projects that are being funded by the Interchain Foundation. So the Interchain Foundation is the grant-making body that's powering a lot of the development work across the Cosmos ecosystem.
Yeah, I'd say that just from my observations, commercial uses of TLA plus are usually more. This is just from my observation in blockchain space. So once again, like take it with a heap of salt. But the commercial uses of TLA plus are more for like protocol modeling, and like you said, like modeling distributed systems and stuff like that as abstract transition systems, and then trying to show that they won't go wrong, quote unquote. And K is a little more focused on programs in programming languages. That doesn't mean TLA plus can't be used for making a model of a programming language and verifying correctness of it. And that also doesn't mean K can't be used for doing protocol modeling. It's just kind of the ergonomics of the tools point them in the directions they've gone.
Great, thank you very much for the answers to Everett and Patrick. I appreciate that.
I got another quick question. If I wanted to write a Cardano smart contract, can I pay you guys to write it, or do you only do verification?
Depends on how much you're paying. No, just kidding. We haven't done any engagements like that before where we develop smart contracts. So I probably not, but I mean, I'm not going to say no without listening to your offer.
Yeah, I would, not that you're looking for someone to second Everett's answer, but I would say we have not to date been asked to write any smart contracts. Now, what we are doing, I will say this, we always encourage folks to, let me turn on the video. We always encourage folks to engage with us as early as possible in their own development process. You know, in the design phase to begin with, when they're actually thinking about their project. So it is something maybe we could work alongside developers that are actually writing a smart contract for whatever ecosystem, but it's not something that we've done ourselves to date.
Sorry, last question. Just from you guys' insider perspective, how's your opinion been of the Cardano team? And sorry to keep it so focused on that. I was just curious.
So, you know, I think I'll say it like this. I think that so we've worked extensively with IOHK on a variety of projects. They're arguably, as Everett mentioned, they actually really funded our entry, so to speak, into the blockchain space. We continue to engage with them. We continue to work on a variety of different projects, and I think that'll happen, and that will continue into the future. IOHK and Cardano are big believers in rigor and verification, and so it's definitely a good match.
Yeah, I don't foresee us not working with them anytime soon, honestly. So we kind of are developing a lot of the tooling for them, and we probably plan to keep on doing that with them as well. So.
Yeah, I have a question for Everett. You mentioned the bug that you guys found in the Ethereum 2.0 contract where you had to go back and help them rewrite that. Just out of curiosity, had they been following case specifications when they wrote the first version? How early had they engaged with you, perhaps? I guess I could ask. And would it have helped if they had done something differently in their original implementation, looking, you know, just sort of looking at this as a case study?
Yeah, I can talk about that a bit. I wasn't the lead engineer on that project. It was our director of formal verification, Dejun Park, who's kind of the guru for that sort of thing.
Is that the deposit contract, Everett? Were you referring to the deposit contract? Yeah. Okay.
So the issue was if so the deposit contract is a contract that you would send your Ether to move from the ETH1 to the ETH 2.0 chain, right? So they could do this upgrade, and it's just a smart contract, so obviously it can have bugs in it, right? And they wrote it in Viper, hoping that the Viper compiler, being kind of simpler or smaller, would produce EVM bytecode that is more likely to be correct. They did involve us very early in the process, and we stayed kind of quiet about it very early in the process as well. And we had a really good relationship with them, a lot of back and forth. So very happy to have worked with Danny Ryan and his team on that one. And the problem was that the Viper compiler had an edge case where, in normal use, if you went through the web browser to interact with the contract, there wouldn't have been any problem, but you could craft a transaction which would kind of throw your ETH away instead of depositing it on the ETH2 chain. There's obviously a problem for people who want to migrate to ETH2. So we just kind of quietly had them rewrite it in Solidity instead of in Viper. The reason being that the Solidity compiler, while it's bigger and a larger code base, harder to be sure about, was more mature than the Viper compiler was. And then we fixed the bug in the Viper compiler first. We fixed the bug in the Viper compiler, and then the verification went through. And so at that point, we were pretty confident, like, yeah, you can use this as the deposit contract, but they wanted to be extra sure, so they rewrote it in Solidity. We redid the verification. It went a lot faster the second time, and then everything went smoothly from there. So does that kind of answer your question? It took maybe I can't remember, maybe like 3 months total.
Sure. Yeah, no, that's absolutely, that sounds like it's the right process to do, to try it out and have different iterations and just make sure everything is right when you kick the tires. I think we've had some really great participation. Do we have any more questions? All right. Well, we're getting towards the 50-minute mark, which I'm always told is the time when people start to glaze over. So I'll give you guys a chance to just sort of wrap things up. And yeah, then we'll close out.
Great, thanks. It's been great to present with you guys. Like I said, we're always looking for talent. So if you know anyone who wants to work in formal verification, on formal methods, security auditing, whatever, go to our website and we can see if it's a good fit. Otherwise, happy to have been here, happy to present. Patrick?
Yeah, like Everett said, thank you very much for inviting us. Always a pleasure. And yeah, let's keep up the conversation. We can go ahead and maybe in the chat, Everett and I can put in our emails. Feel free to send over any questions you have, and we can, try to get them answered. Thank you, Adam, for inviting us.
Well, it was an absolute pleasure to host you guys. I'm going to go ahead and make sure we put this up on our YouTube channel for Champaign Blockchain, and I'll post your contact information in our meetup group so that people will be able to access that. Of course, you can always also go to the webpage, which I'll put that in our various social media platforms as well. And we'll look forward to hearing more about what you guys are doing and having more presentations for the Champaign blockchain in the future. Thank you everyone for coming.